Good morning, everyone. This is Hardev Sandhu from EREC in Belgrade. I'm the coordinator of the EREC seminar series, and this year we were a little behind on scheduling the seminars. So this is our first seminar for this series. And today we have Dr. Troy Jensen with us. Dr. Jensen has been working at the Center for Agricultural Engineering, which is a research center of the University of Southern Queensland in Australia. And he's working there since 2009, and where he has been primarily focusing on yield monitoring and precision agricultural applications for the Australian sugarcane industry. He has also been developing innovative market entry solutions to precision spot spraying and providing technologies to monitor crops at a very fine spatial and temporal scale, along with using his extensive agricultural experience to provide valuable postgraduate student supervision. His current position is Associate Professor and Principal Research Fellow in Precision Agriculture at University of Southern Queensland. He is currently stationed at EREC in Belgrade on a Fulbright scholarship and also visiting scientist appointment until the end of this year. So we welcome Dr. Troy Jensen.
Thanks, Hardev. Hopefully everyone will be able to understand my accent, so I'll try and not use too many Australian terms because I'll probably get some blank looks from you guys. Thanks, Hardev. So firstly, I wanted to do a little bit of a comparison between my university in Australia and you guys here. So that's my university in Australia. I used the insightful Wikipedia to generate these numbers for you guys. The numbers that Wikipedia had for my uni were somewhat limited, but you can see that the campus, that's only part of your campus. We're much smaller. Although we have got supposedly 27,000 students, most of those are external. So USQ has been mostly an online university, but for some subjects, particularly in the engineering space, it's actually on campus. So I would think of that 27,000, we might have 5,000 students physically on campus, as opposed to you guys that have got 50,000. So there's in a lot of the stuff we'll look at today, there's a 10 multiplier in those sort of things. Toowoomba, where the campus is about 130 kilometres, say about 80 mile west of Brisbane. And I think I've got a map coming up that we can look at as well. So now a US-Australia comparison. So those maps are the same scale. So if you put the map of Australia over the top of the map of the USA, and there's some numbers in there, if you count Alaska and the territories from the US, then you guys are a bit big. Well, I think 9 million, sorry, it's in kilometers, but you can get the scale of things going on in there. But if you look at the contiguous states of the USA, then Australia is actually the same size or a little bit bigger. So land area is about the same. But our continent, Australia, is an island, so there's issues around border security and diseases and all of those sort of things. But that's a story for another day, if you're interested. So we're an island as opposed to you guys with land borders north and south. But we've got 25 million people approximately, and you guys have got 330. So that's there's a 10 scale factor in there as well. Other things, we drive on the other side of the road, so we drive on the left because of being a British colony. Legal drinking age in Australia is 18, is one of the things. One of the other differences, Australians don't tip. It's generally par for the course, and some of that is being driven by the minimum wage. So in Australia, and so those numbers there are US dollars. I converted So Australian minimum wage is about double the minimum wage of the US. So, you know, the waiting staff and the hospitality staff don't expect it. So hence Australians don't essentially give it. Australians tend to abbreviate everything. And so after I leave, you guys, I'm going to set you guys an exam so that you guys can maybe pick up some of those Australian terms that you might hear me say some of them. So I'll have a question there, not today. I mean, I'm meeting just before Christmas, before I leave here, that I'll have a questionnaire to see who knows what some of these silly Australian terms mean. Australia's using the metric system. We write our dates backwards. So in Australia, it's always, you know, day, month, year, as opposed to the other way around that you guys use. Australians must take swimming lessons at school because most of the population live within, say, 50 kilometres of the coastline. There's not a lot out in the middle of Australia, the outback. And so we're surrounded by water. Most of the lifestyle is along that coastline, and so swimming is quite important. Australia's, it's compulsory to vote, so you don't have a choice. So you can get fined if you don't vote. And no one in Australia carries guns other than the police. And so some of the conversations I've been having in the breakout room with some faces that I recognise in the crowd are, what about all these things in Australia that can kill you? So I'm going to go on a little bit of a tangent and give you guys some ideas of the things that are out there that are dangerous in Australia. That thing that you can see there is a box jellyfish, and so it's supposedly the deadliest animal in the world, and so they're off the Australian beach lines. Generally, there's warnings when they're around, and if you're in that sort of an area, when you go, people still go swimming, but you put on leg stockings and the like to stop the tentacles of these things from getting around your legs and the like. And so there are ways around that. So that's one of the things that can do you some harm. And there's other things. So we're talking with other peoples about this, about the other things that are out there that can do you some harm. That snake that you can see there's a taipan, and so it's the most venomous snake in the world. And so that's along the Queensland coastline. Other things, crocs like this one. You guys have got the gators, we guys have got the crocodiles. And so they're huge, they're aggressive, opportunistic, eat all sorts of things, including people. And so that clip at the top is a newspaper article from 2 days ago. The Courier Mail's up is the local Brisbane paper. And so that's from an attack in Cooktown. So Hardev visited us last year. You didn't get to Cooktown. I don't think Cooktown's north of Cairns on the Queensland coast, but there's a guy attacked by a crocodile. And so he survived it, but he had bites to his legs and his arms. He was claiming it was 4.5 meters long. So that's 15 foot. And how he got out of it is he said it was attacking him, and so he jammed his fingers in its eyes to try and get it to release. And obviously it's released him, and he's survived this croc attack encounter. And so it's reasonably common, but having said that, there's only 25 million of us, so that, you know, the numbers are a little positive. So on the bottom there, I said the information that I found was 24 deadly attacks between 1975 and 2009. So I then went Googling. So some other interesting things that can do you some harm and potentially kill you. Top left is the blue ring octopus. So a sea creature. Obviously, sharks can do you a little bit of no good. There's a stonefish. I haven't got stingrays on there because I think you guys know the croc hunter the crocodile man, Steve Irwin, got done by a starfish, but that was very, very isolated. Some of you guys have been talking to me about spiders. so that one's a black widow. I think you call it a black widow here. We call them a redback spider. So I think they're quite similar. So the ones you guys have got are dangerous as well. That one's a Sydney funnel web, supposedly about 5 centimeters. So I had some comments around, are they as big as your hand? But no, there are some, but not, those guys are the deadly ones are supposedly about 2 inches in size, but live in things and like to climb into your shoes and that sort of thing, climb into your houses to get away from other stuff. So, and other snakes. So that other one was the taipan. This one's an eastern brown snake. And so I think Australia has 7 of the top 10 deadly snakes in the world. The good thing about the snakes is that, if they feel you walking, they feel your vibration, then generally they're not aggressive. They'll go away from you. So encounters are generally very low. And it's generally, if you've got one of these in your backyard, you're out there trying to kill it. So it's then aggravated. So it then bites you. And so that confounds the issues. I found some statistics talking about like deaths in Australia from wildlife. So up there it says 2 people die per year from snake bites on average. So some years are higher, some years are lower. 2 people die from croc attacks and 3 people die from shark attacks per year. But the positive of all of that is, well, not if you're a tourist, that's a reasonably positive because the numbers aren't high. The problem is that if you work in agriculture, 30 people die per year on average from animals, from horses and from dogs. So you're probably more likely to die if you're working in agriculture than you are to die as a tourist. So if you guys come and visit, then that's a good positive for you. The cattle deaths are obviously from handling and the like, but also when cattle escape out onto the roads, you're driving along in your car at night time, there's a car, you try and swerve to miss the animal, car rolls, hits a tree, car accidents and that sort of thing. And so adaptations in Australia are on your pickup is called bull bars. And so, in rural areas, then they're quite common, both for cattle, particularly for kangaroos as well, because there's more kangaroos in Australia than there are people, so they're everywhere. And quite hard to predict when you see them hopping along and you're going, which way is this fella going to go? So the last thing you want to do is have one smash into your front. You've got a hole in the radiator. You're then stuck because of the distances and all of those sort of things. So lots of the pickups have bull bars or rhubars, we call them, but also the semis or the prime movers as well, so that you're not incapacitated. And if the animals don't kill you, the distances will. So, lots of areas that are very sparse in population. Like I've had some PhD students from Asia come out, and we drive 5 hours to where we're going to do some research in sugarcane. And I generally drive the shortest directions rather than the most populous routes, and they were scared. What happens if you break down out here? Yeah, that's fine, but 400 kilometres to the near from you've just passed a pub where you have a beer or fuel stations or water or all of those sort of things. Or maybe the food might kill you. So is any of you guys, have any of you guys seen Vegemite or tasted it? Okay, a couple. Good, terrible, yeah. I love it. As a child, you'd have it on Vegemite, or you put it on your toast, and so that's what you give small children from when they can't even walk, giving the Vegemite. Good for vitamin D and supposedly a mosquito repellent as well, with the vitamin D that's in it if you've got eating Vegemite. So the food could kill you as well if you're not acclimatized to the food. Lots of interesting creatures. I was talking, is it on here? Here's your sugar glider. So Yeah, sugar glider, I did some Googling. Sugar glider is a native Australian animal. So, you know, kangaroos, you see there. Wallabies are a smaller kangaroo. Again, they carry their joeys in a pouch. All sorts of other animals, echidnas, a bit like you guys have here, porcupines, a bit like that. And then platypuses, Tasmanian devils, we've got a wombat over here, and then all of the bird life. So yeah, lots of different things because of us being an island where, you know, a lot of these things have been protected for thousands of years. So that's enough of the Australian pitch. I thought I should also talk about some of the things that areas of interest that I've been up to and where I've been researching and the like. When I first left university, I started working in the Department of Prime Industries, it was a state department, not like the the Federal Department of Ag over here. Each state has their own departments of ag. So I started working there, and the work that I was doing was around developing grass seed harvesters to harvest native grasses. So when you're hiking in the bush, the stuff that gets caught in your socks that you know is a pain to try and remove out of your socks, those are the grasses that we're looking at trying to harvest. And so there was some guys over here, DeWald and Beisel from Oklahoma, developed a brush harvester. So it's got bristles that rotate upwards at the front. So we started developing some similar things to that was appropriate for the Australian species that we were looking at harvesting. And that was then used to regenerate areas in the field where it had been denuded due to sheep grazing pressure. This is about 600 miles west of Brisbane. So this is getting out into, like, particularly that top picture is proper outback sort of stuff. And so you can see it, and this was a good season. So you can see there's a lot of vacant area, lots of dirt that you can see, soil. But this is sheep grazing areas and quite extensive grazing areas. So I then worked on another project which was looking at controlled traffic farming. So that's tram lining, or keeping all implements in the same spot in the field rather than random traffic. So this predated GPS guidance on tractors, but guys were starting to look at trying to take the tractors and all equipment over the same spot so that you had efficiencies in, you know, reduction in overlap, reduced fuel costs because you're not tilling the whole area. You can do selective tillage, greater yields, more efficiency, and all of those sort of things. So I did a fair bit of work in that space, and a lot of this was being driven. So this is in the 90s, driven by fuel costs, particularly in Australia. And so guys were starting to match up equipment rather than random traffic and the like. And so I was conducting research in that space. And so did a fair bit of work both with cone penetration resistance, which is pushing a spear into the ground to measure the resistance of insertion of the spear, to look at as an indicator of soil strength, but then also doing other things where this is a corn crop. So then in the field, harvesting along with a small plot harvester, individual rows that we could then look at rows across the front of the grain harvester to see spatial differences within the crops. And so we would harvest along, collect the corn that had been harvested off 25 meters, stop, bag it, harvest the next one, harvest the next one, harvest the next one, so that we had an understanding of what was going on in that field. So this is results from using that little plot harvester. So where I've got row numbers here, this is planted on 3-foot spacings. So we had a 30-foot front. So there was it might have been just less than 3 foot. So we had 12 rows across the 12 rows of, I think this is a sorghum result, across the front of the harvester. So using the plot harvester, harvest one row, harvest the next row, and aggregate that together. at about this time, we're starting to look at yield monitoring on grain harvesters. So, you know, from a grain harvester that might be 30 foot wide, you end up with a value about every second as the harvester's moving through the field. But the data that's in there, there's lots more variation. If you sit on one of those things, you'll see even within the 30-foot front, this area is different to that area. So even on a, you know, so you've got one value for, you know, the full width, but what's happening from a plant scale is much finer than that. And so we're interested in what's the impact of these wheel tracks and compaction on the yield. And so the harvester, you have one value, but there's lots more information in there. And so that's what I was up to here. So the farmer had a few wheel tracks through the field that we then used that plot harvester to look at yield variation across the row, across the width of the harvester. And not surprisingly, the lower yielding bits of that field were where all the wheel tracks were. So we were trying to quantify that to provide information for farmers to take the next step to move towards automation and the like, and adopting that controlled traffic strategy. Had another project that was then looking at yield monitors on grain harvesters, but we were then also starting to look at protein values as well. So that relationship between yield and protein in cereal crops. We were led to believe that there was protein monitors available that you could mount on the harvester, but it didn't turn out. So we had to come up with methods of providing that layers of information ourselves. So we developed a platform between the wheels on the grain combine. And so I then sat in there collecting samples that were geolocated. And so we had about 1,000 samples from 100 acres in that field, which was geolocated, which we then took back to the lab and analysed for protein that allowed us to generate a yield map, which we could with the yield monitoring equipment on the harvester, but we could then generate a protein map that we could then start to look for yield protein relationships. In Australia, we're generally water limited, and so that relationship was driven by water. But in some instances where water is not limited, then that relationship tips the other way and becomes driven by the nutritional status of the crop. And so we're looking for relationships and in that yield protein relationship to see, are there any other management decisions that we might be able to make? This was a barley field, and so you know, the harvester was going backwards and forwards, mixing all of that up. So, you know, you end up with one value, but there's lots of other information in there that you could use. And so we started looking at nitrogen removal and other ideas that we could start to have a better spatial understanding. So when we're doing that, we thought, well, you know, a point of reference of protein at harvest time is a little bit problematic. You can only use it retrospectively. Wouldn't it be nice if we could look at some satellite imagery or something during the growing season that might tend to indicate that that's the higher yielding bit or the higher protein bit, the lower protein bit? And so we started looking at remote sensing, and that was where I did my PhD. So I started putting cameras in remote control planes. That little black dot under my red dot is the lens of the camera poking through. And so we then started using a spare channel on the radio receiver to depress the button to take images. It takes a bit of skill to operate this thing, which was not me. The 7-foot helium balloon was a bit more my style, where you have a fishing reel, let it up above the area, take some images and the like. And so that date on that photo is 2003. So that was when we were doing this sort of stuff. Developed a 2-camera system. So that's a 1 megapixel Kodak digital camera. When digital cameras first come out, there's 2 there because we had one that was capturing the color information of the light spectrum, and one had been adapted to accept infrared. So we could do color and near infrared, which would allow us to then do NDVI, which is a a vegetation index based on the red and the near infrared, which accentuates biomass and that sort of thing. So we looked at some fertilizer trials. So this is a fertilizer trial site, and I've picked 0 and 120 units of nitrogen there. And so we're looking for that relationship between yield, protein, imagery, and the like. So that one's the color image of the previous one laid over the top of the other one. So maybe I'll just draw your attention to that little bit there. I'll just toggle backwards and forwards. So you can see, it's much greener in the color, but in the infrared, it's much brighter. So, that's the reflectance of the chlorophyll reflecting the infrared light, which is why people quite like using NDVI and that red and near infrared band for looking at biomass and the like. So started down that path, but when you've got a sensor, we started looking at other things. So then we're looking at water, lettuce growth rates due to non-uniformity of irrigation water. So putting the balloon up above lettuce crops, looking at head growth rate sizes. So remember, this is 2003, 4 in that sort of time range. So about that time, I finished my PhD and then moved across to the university, to USQ. So the first project that I started working on there was around yield monitoring on sugarcane harvesters. So a quick snapshot of sugarcane in Australia. So this is part of Queensland that you can see there that I've highlighted by that little coloured area on the map of Australia that's there. So USQ, I didn't have it on map, but is located under the R in Brisbane there. And so that's about 80 miles west of Brisbane. So out in here is lots and lots of not a lot. And so the thing with Australia and where sugarcane is grown is that there's a Great Barrier Reef is along here. So I think it was Ellen DeGeneres on the Ellen show was out there doing stuff at the Love Heart Island, which is out there on the Barrier Reef. This is, went snorkeling with so that's my daughter snorkeling out on the Barrier Reef in the middle of COVID. So we were supposed to go on a family holiday. It didn't happen. I thought we'll go up to North Queensland and have a look around. So that's my two of my children out on the Barrier Reef looking at coral and that sort of stuff. The problem with that is that, all the sugarcane's grown within, say, 50 kilometres of the coastline, lots and lots of locations where you get an indication of the material that's flowing through the harvester. So those boxes are where I've had sensors on the harvester. So the first spot is between the feed rollers. So and I don't know how much you guys have seen, you guys are aware of the components of a sugarcane harvester? Some are, some aren't. So there's a couple of feed rollers in there that's pushing the material up towards the chopper. So that's where the first one is indicated. So if there's no material in there, those rollers under the force of gravity are together. So, but the more material that goes through the harvester, the rollers are forced apart. So the distance between those rollers is a reasonable indication of the material that's flowing through that harvester. Similarly, the amount of power required of the chopper to cut the long stalks into billets is also an indicator of the amount of material. So having an understanding of what pressure ranges are there is also indicative of the material. Similarly, the power that's on the elevator. So obviously it takes some power to make the elevator turn, but any material that's on there is going to change that as well. There's also the capacity to put a load cell underneath the floor of the elevator to look at the material that's also passing over that. And there's a guy, Randy Price, over at Kansas State, I think, that also was developed a sensor that was looking up under the floor, looking at daylight and darkness as the materials moved past up through the floor. And so I had a 3 different harvesters instrumented with all of those bits and pieces. So this is my shorthand for So this CP is chopper power, EV's elevator power, LC's load cell, RO is the separation distance of those rollers. So we did numerous trials of harvesting through a field and then harvesting the material into a weigh wagon, which we then used to generate the expected yield map over on the right that we were then comparing each of these sensors to. And so there's, this was stopping every 50 meters, the weigh wagon section, which made this a little bit coarser than the actual values that we were able to record. But the good thing was that, the areas, with red being poor and blue being high, we were able to fairly reliably collect or indicate in those fields which is the low bits, which is the high bits, and which are the bits in between from a spatial perspective. So this was a reasonably good result. The sequencing of harvesting in Australia is a little bit different to here. So each of those colours in that left-hand map is an individual harvest event. So that's cane that was harvested on one day. And so I don't know if you can see it, but there's quite a range in there from, I think that the green stuff up the top was harvested in May through July, and so over several months this crop was harvested. So it becomes a bit of an issue about, the increased growth time, but also getting the consignment right. So the amount of cane that's cut that day is accurately attributable to that field. And so we did a fair bit of work in that space so that the resultant yield map that you can see is consistent with the land, the soil type, the things that about the field, the slope, the elevation, where there might have been some soil brought in or where there's been some leveling gone on, and the sort of the natural relationships from a spatial perspective. So, to have a map that coincides with the landform is a good result. And so this is in the Burdekin, which is all irrigated. So they actually do burn here as well. But you can see there are some parts of that field that's 280 tonnes per hectare. So the yields are particularly impressive in this part of the world. So we also did some evaluations. So we had the first John Deere yield monitor that came into Australia was on a harvester that I put several of my sensors onto as well, so that we're looking at how the relationships between the yields from the sensors that I had on there and looking at what was going on with John Deere. So we did some logging with the John Deere yield monitor. Rather than weigh wagons, we were doing it commercially. So we were tracking the haul out bins that you can see on the right there going into the field when they got, I don't know if I got it when, no, I didn't have that picture. So when it got tipped into the wagons on the trains, tracking that to the mill to see how this was working. And so this is a yield difference between the tracked to the mill values to what the sensors on the harvester were looking at. And so, most of it, there are some values on here that are above 5%, but the majority, so that's the value through the middle is what the actual value was, and we're looking at whether we're above or below that average is what I've depicted there. But most of the time, there were some outliers, but most of the time it was with, plus or minus 5%, which is, the scale or the value that the farmers would be, you don't need 1% on a sugarcane harvester because you're not going to be able to deal with it anyway. So, if it's within, 10%, then that's sort of, the accuracy that you require to make a different management decision. And so another way of depicting it, so this was the bin averages on the y-axis versus the actual predicted values from the yield monitor on the x-axis. And so R squareds of the bottom right is R squared of 0.86, which is pretty good. So then the goal is that you've then got several layers of information. A single yield map is probably not going to enable you to do much. You need to have an understanding over, is that relationship that you've got stable with time? 1 year might be high, 1 year might be low. But is it explainable? Are you confident in making a decision based on that information? And when you can get some real value is when you align it with some satellite imagery, which is the NDVI, the NDVI that you can see there. Multiple years worth of yield maps, and you might have an EC map in there to try and see if you can determine what the drivers are of the production that you've got. So, with that understanding, the farmer was able to look at some variable rate applications of gypsum to overcome the yield constraints that he had in that field. So I also had some student that was doing some work on sugar losses. So there's quite a lot of sugar in Australia gets lost dependent on primary extractor fan settings, ground speeds, pour rates, and the like. So we had a student that was going out into the field, putting tarps out, collecting, so that you can see there's some blue tarps on the ground. So that was collecting all of the material that went onto those tarps. They were then processed through a mulcher. It was then subsampled. It was then used some colorimetric analysis to look at how much sugar juice, which was both from the cuts of the billets, but also of small parts of billets going into the primary extractor and getting sprayed back out over the field. So depending on the settings of the harvester as to what was going on in there. So he did a fair bit of work, and so we were looking at the effects of pour rate due to nutrition on the amount of material that was getting pushed into the front as to how well the cleaning was done on the harvester. And so some of his results are in this table, but so you can see that line is the amount of sugar that was lost in the field dependent on so those three columns are fan speed in RPM, and the 4, the 5, and the 6 across the top is the ground speed. So it's that relationship between fan setting and the amount of material you're trying to push in the front as to how good of a job you were trying to do. But the worrying thing is that if you really crank the fan up to try and get a nice clean sample, because remember, 90% of Australian cane is cut green, so you've got to get rid of that leaf material. The tendency is to really crank that fan up, get rid of the leaf material, so you've got good density in the bins, but with that comes 26 tonnes per hectare of sugar being left in the field. So, when you're talking 100 tonnes per hectare, a quarter of your the desire to get nice, clean billets, good density in the bins from a factory perspective is quite detrimental to a farmer. So, back the harvester back, slow the speeds of the fans down so that, you go to all that trouble of growing it. Why not try and recoup it through the harvesting process? And so that's a continuing conundrum, continuing problem with harvesting in Australia, and who's prepared to foot this additional cost. I then started doing some work with drones, and so I then had a project where we're looking at using existing spray technology. So that's any in Australia, any self-propelled sprayers or any sprayers that are less than 10 years old have the ability to turn bits and pieces of the boom on and off. So we thought, well, let's try and utilize that capacity to then try and make some decisions to turn those sections off so we can go down the path of precision spot spraying. So we were using a Phantom 4 Pro off the shelf with a traditional color camera with some software that a colleague of mine developed. So we're putting it through a orthomosaic to generate a big orthomosaic image that was pushed through my colleague's software that enabled us to identify the weeds, generate a prescription map that we could then push to these sprayers and then do some section control on a boom. So I've got a little. So the map on the left is this one here is an orthomosaic. The one in the middle is putting it through the software that we've generated to generate the prescription map. and the image on the right is it spraying through the field. So I've got a little video. Lucky you're here, mate. Oh, I did have it on there, but yeah, that's it. Yeah. Yeah. So if I go. So that's a little sprayer that we've had. So it's got 5 sections behind that. So behind the tractor is 1 section, then 2 off each side. So we flew it with the drone, identified the green bits. Those green bits, we were using a rotary hoe behind the tractor, lifting it up to leave those little green bits and putting it back down. So wherever you can see there's a bit of green, it's picking it up. It could be multiple sections turning on and off, but you can see that it's controlling them individually, except when he goes off track, but he comes back on track now, and then it's turning on individual bits. So it was a good example of this application actually working. So it was just pink dye in the sprayer and no chemical in there. Thank you. I'll play the video. So we put bits of paper out in the field next to a range of weed sizes and went out with the pink dye and sprayed it. And so you can see some of those, you can see that there is, it's probably not real clear, but there is some pink spray over those bits of paper that were there. So of the weeds that we targeted, we actually hit 93% of them. So we thought, well, that's a fairly reasonable result for a very low cost solution at precision spot spraying. But as part of that, then when you've got so we started looking at other things. So this is now looking at a sugarcane crop. So we did the same thing, but here we were starting to look at, if we know where the sugarcane is and we know where the sugarcane shouldn't be, we can start to do some more targeted inspections of the field. And so that was then, so the image on the left is the image captured with the drone, orthomosaic together. The middle image again is the putting it through the software, picking the bits of green that are there. And so that the blown up image on the top right-hand corner is the actual crop. So we've got sugarcane growing in there, but we're able to pick the weeds within that sugarcane crop, was what we were trying to do here. Then we started doing other things as well. So the sugarcane grower, the farmer that I was at, was also growing pineapples. So he said, I want to know how many pineapples I've got in the field. I want to know when they're flowering. And so rather than now looking for green weeds in the field, we said, well, I wonder, can this thing that we've developed, can we try and pick the red flowering of the pineapples, so that you've then got an indicator of how many plants you've got in the field. The beauty of pineapples are, if you know when the pineapple's flowered, you know when it's going to be ripe. So depending on the time of the year, it could be 8 months from when it's flowered to when you want to go and harvest it. But so all pineapples in Australia are harvested by hand. When we're paying the $15 US per hour to harvest them, there's not much revenue left in there for the farmer. So we were thinking about, how do we mechanize the harvesting process? So if we know, so one thing is to know which pineapple you've got to pick. We can start to go down that path by looking at, if we know when it's flowered, we know when it's going to be ripe. So we can make some decisions around flowering, and a lot of this is natural flowering too. So some of it was around, well, why is this bit of the field flowering naturally and this bit's not? So it's that spatial understanding of, do we understand the system that we've got? Yeah, you can go down the mechanical harvesting, but it'd be nice to know, well, why is this bit flowering and that bit's not flowering? It'd be nice if the whole thing flowered at once, so then we can just go through and harvest the whole lot. The more times you have to go through the field, and some other stuff coming up, is creating those issues as well. So how do we make best use of the facilities, the manpower, the labor, the workforce that we've got? And so we started down the path of you know, going through the fields, counting the number of plants as what's happening here, counting and looking at where the pineapples are actually flowering. You can see those red dots that are in there, and then trying to secure funds in that space to develop this idea. So the beauty of a drone and the ability of going out and flying it is that you can go out. So that series across the bottom that you can see is the exact same pineapple at a week into space. So what we were trying to do is we're flying it weekly, trying to pick when it actually when it started to flower, so that we could then go and do those other things that we were looking at. And so across the bottom, you can see that the exact same pineapple. So over here at about week 5, you can see that it's actually flowered. So here we were looking at on the HSV color wheel, which is looking at the colors so that the software could go down to that center of that pineapple, pick out 10 pixels, have a look at the color that's there, and make some judgment. So we've got it in digital format, so we can say, you know, above a certain number over on this color wheel means that it's actually flowered. So we can look at, you know, of the plants that are there, you can track it over time, you can potentially do predictions, and those sort of things is where we were looking at going to. Finally, so pineapples were fine. And so we then started looking at, so this is a field of broccoli. So this was seeded broccoli. So you can probably just see, so that number 97 is a broccoli plant. So it was only just detectable from the drone. And so I've got a time series here. So you can see that this is 2 weeks after that previous image. And so you can start and the beauty of drones with RTK on the drone or with targets in the field, you can get to within a couple of, you know, within a centimetre each time. So you can do this layering of information like I'm doing here, so that you can then do predictions or growth rates or other things that enable you to make a much more informed decision about what you've got. So what we're interested in here was that, you know, there's areas in this field where, for whatever the reason, whether it's seed soil contact, whether it's a previous land preparation, whether it's compaction, whether it's poor planter engagement or whatever, you're getting this variation in the field. So if I just go back a couple, so you can see, you know, you can't see much there. You can see there's start to be something happening there. We have got plants there that are growing in this gap, but, you know, they haven't continued. So, I mean, as an engineer, I want to know what's going on in there. Is there something there that I can remediate, or can I control it? Do I understand what's going on, or do I just have to be able to deal with it come harvest? So these guys are having to deal with it come harvest. But the problem with that big gap at the broccoli 97 is that all of the plants adjacent to that are now getting more water, more fertilizer, more sunlight, are going to grow quicker. They're out of spec quicker. You've got to be able to deal with that from a farm management perspective. This is in the middle of COVID. And so, you know, with half the workforce that they would normally have, where do we make best use of this workforce that we've got? Do we throw them at a really spatially up and down block, or do we say, well, we forget about that, we're better off making use of our workforce going this way? And so, you know, lots of guys, COVID's been a good thing from that perspective of making people rethink their whole production system, you know, because you can't get workforce, etc. So, and so this is it getting, so, you know, as it continues to grow, you know, those plants that were very, very slow do eventually start to fill the gaps in, but there won't be any broccoli harvested from that area. So is it a seed quality issue? You know, all of those sort of things. If it's something that we can control, then yes, take it on board to control it for next year. But if it's not, then how do we deal with it? And so that image is where there'd been one pick done through that area. So that broccoli 97, because it had all that space around it, it was harvested and it was gone off to market before the other ones around it. But those ones that are north of that one, they're not going to be any there. So it's missed opportunities, and how do we make best use of the things and the time that we've got? And so we then had another student that was again did the same thing, and so he was out measuring heads and looking at. So we've got two supermarket chains, Coles and Woolworths in Australia. You guys have got a few more over here, but so these guys were picking it into these black plastic crates that were going straight into the supermarket. So they were trying to aim for the premium grades, and so the student was then, so the different colour bands is WW is Woolworths specification, the orange in there, gator colours. Look at that for a stroke of luck. The orange colour there is then the second grade. So looking for relationships within the field and how that might marry up with the spatial variations that we're looking at from a drone. And so that then led me to apply to Fulbright with that background. I'd had some previous discussions with Professor Robert Gilbert through IWSCT and met Hardev in Reunion, I think, and thought, well, let's give it a try. And so hence me getting over here on a Fulbright, but as part of that, hence also me applying for a visiting scientist for the latter half of the year. So I'm here for 4 months until June on the Fulbright, and then as a visiting scientist till Christmas time. And so, well, that was some information that, well, so I think, from all of that stuff that we've been talking about, I think it's got discussions with Hardev around, muck fires and gaps in your sugarcane. So that's an image that Hardev flicked over to me that we run through our system to see, what's going on. There's some similarities with another student I've got coming from Thailand. This gappiness of the sugarcane crop is of concern in Australia. Both Hardev and I talked to guys in cane growers in Innisfail in Queensland, and so that gappiness, so we, also from a Nicaraguan perspective, they go in and re-hand plant the gaps, and their yields are staying continuous. In Australia, it's the base cutters, it's the compaction of the harvester, it's the compaction from the haul outs that create those gaps in the sugarcane. It gets to a point where it becomes uneconomical to return it over again, plough it out and start again. But if we can come up with the understanding of what's going on and the ability potentially to remediate it is what we're hopeful for, which has got application to you guys here, us at home, Thailand, Nicaragua. There's all sorts of moving dynamics going on in there, and potentially stuff in horticulture or something that might come when someone comes into the office and has a chat and go, oh, well, that's a good idea. Maybe we should go down that path. I'll shut up now because I'm done. But any questions from anybody?
Anybody has question from Zoom? Please just unmute yourself and ask your question. You can also put your question in the chat box.
Got a question up the back from so the question was about spot spraying. Oh, so there's quite a lot of, the leading, because Australia's so the scale is quite large and Australia is generally water limited. You're trying to retain all the moisture that you've got. So the idea, so the leading growers are generally going into precision spot spraying. So John Deere have developed a Jensen spray, which has got sensors that control individual nozzles. There's also green seekers. There's also weed its that have got cameras and sensors. The problem with that is that and I'm talking Australian dollars now, it's about $5,000 a metre for that, put that equipment to retrofit it onto an existing boom. So if you're talking a 35-metre sprayer, which many of the big self-propelled ones are in Australia, you're talking $200,000 worth of sensors that you're throwing at this piece of equipment to enable you to do that. They don't work, there are times when they don't do a particularly good job. There are times they do a really good job, but the thoughts we had was, with a $2,000 or a $1,000 drone, you could potentially get, 60 or 80% of the benefit of this $200,000 or $300,000 piece of equipment with some low cost technology. So it gets you a long way down that path of being able to do more sensible things with low budget, and the entry into that system is then much cheaper. So there are lots of guys doing it, and there are lots of contractors that go out and provide that service. But we were thinking, there's an opportunity for guys that don't necessarily have that amount of capital or that scale that might want to start to go down this path.
I have a question. This precision agriculture is an advanced technology. So does it has any limitation when we apply it? For example, it needs the ground to be very flat, or does it has a limitation for the area for the field?
Depends what sort of commodities you're looking at. I mean, so the horticultural stuff is quite small areas. So you're not going to have a yield monitor. I mean, there you need to be able to count individual plants or those sort of things. But, that drone that we were using is only, the Phantom 4 flies for about 22 minutes. So that Phantom 4 is not going to keep in ahead of a 35 metres spray rig that's going at 30 k's an hour sort of thing. So, it's got to be appropriate for the use. But drones and added spatial understanding around what's going on, the ability to use your drone to go out every week, because some of those horticultural crops, as you guys well know, are probably only grown for 6 or 8 or 10 weeks and then they're gone. So, but you have to be on top of all of those things that you're doing, as opposed to a sugarcane crop that, might be 4th or 5th return. So you've got more time, or cotton crops or tree crops or those sorts of things. So it has to be, it has to be appropriate for the use. And you have to be able to understand what's going on. If you can, and that's in whatever crop, whether it's a wheat or a barley or a sorghum or a cotton or a lettuce crop. If this area is different to that area, then you need to understand what's the driver, what's causing this to happen. Then, once you're confident, if you understand that system, can you do something about it? Can I fix this problem for whatever's causing that? But then the economics then kicks in. Is it economical to do something about it? You might spend more money trying to rectify the problem than what you're going to receive, if you sort it out. And so it's that multi-act juggling that you have to do to understand what's going on.
Troy, I have a couple of questions from Zoom. It's Rosa Mohove from US Sugar. Have you done any research on characterizing soil variability and using the data on precision fertilizer application?
So that multi-layered map that we had there was is that better? Oh, up there. Okay. Yeah. So so that multi-layer map, if I can jump back, started to go down that path. So, yield is one component, but yield is, I'm thinking of this one. So yield is one component that you marry up with some imagery and the like, but, we're using yield to identify the areas that were high and low in the field. You then start to have to look at soil properties. In this instance, the soil was very sodic, which was we were able to detect using EC in that field. So that EC is the red layer at the bottom, which you can see here. The high EC areas were the low yielding, and so that was because of sodicity, and hence the farmer was then confident in making that connection. And then he said, okay, now if I understand what's causing my variability, I'm confident in what's going on, then you can start to look at how do you go about remediating it. And that was what the farmer's decision was, that he'd do a variable application of gypsum, which is the top map there, which enabled him to remedy that situation that he was looking at. So you cannot take one thing in isolation. It has to be, the more information that you've got, the more layers that you can add to your decision-making process, the better the confidence you can have in those decisions that you're making. And invariably soil will be a driver in Australian sugarcane. I mean, it may well be the depth of your muck soils, or what happened last year in that space as well, that you have to understand that dynamic so that you can have confidence in what the decisions that you're making as part of that.
Yeah, I know in Australian sugarcane, they apply gypsum using EC maps, but is there any other nutrient management where they use variable rate application?
So, I mean, if in this field, it wouldn't make sense to the previous, so we've got areas in this field that are, the red areas, which is that layer through there, there are areas in that field that are less than 85 tonnes per hectare, and there are areas that are doing more than double that. So, one of the farmer strategies might be, well, and we put on a lot of nitrogen. So, the discussion I've been having with Hardev is that we'll be putting on 300 or 400 or 500 units of nitrogen each year into that to grow that low level of cane. So if your areas are consistently lower yielding, be it because of soil depth, which is something that you can't change, here it's because of sodicity. So the farmer's got the ability to be able to modify that. So that's slightly different. But if you've got areas because of soil depth or soil type, as soil types might change, there's areas that are going to consistently be lower yielding, then the idea behind giving it all a uniform application of nitrogen doesn't make sense. So, there would be guys that are treating the yield potential by adjusting the nitrogen according to that. And so that's the obvious one in Australia.
There's another question. How reliable are sugarcane leaf monitors when compared to grain?
It's probably a confounded problem around the time that the grain yield monitors have been around. So grain yield monitors come out in the 90s and they're fairly consistent now and reliable and accurate. The problem with sugarcane yield monitors are that there's so many things that can change through the billet sizes, the amount of dirt that's entrapped in there, the leaf material that comes in as well. So, that result that I showed there of, a plus or minus 5% was pretty good. So, it depends on, you're not going, as I mentioned in those slides, you're not going to make, if there was a 1% change in the yield, you're not going to make a management decision based on that. So that 5% is good, that, if the objective is to understand and consistently get the high yielding bits of the field, the low yielding bits of the field, and somewhere in between, you're not going to get it down to 1 or 2% accuracy because of all of the things of, depending on which sensor you pick, the base, if you're looking at the chopper pressures, then it's, how sharp the blades are. They change over time. The amount of moisture that's on the cane changes over time. The cane variety changes over time. When you compare that to wheat or barley, which is a much more homogeneous uniform, consistent, and with less foreign objects and material in there, that, I think, 5 or so % error with a sugarcane yield monitor is pretty good, with all of the vagaries of the things that you've got in there that can control the result that you've got. So when I had the helium balloon, I had a 1 megapixel Kodak camera in there. So it was 1040 by 104 or something, so that was 1 megapixel. The camera that's in your iPhone now is what, 16 or 18 megapixel. The new Phantoms are 48 or something or other megapixels. So, the sensor technology is coming down with every, from 1 year to the next year. The images that I was getting from that helium balloon took, to stitch together 3 or 4 images that I could find known points in and stitch them together, took me several days doing it old school with ERDAS Imagine software. Now you take 1,000 images from your drone, push it into Pix 4D or some other orthomosaic, hit the go button, a couple of hours later, you got the orthomosaic. The technology that's around now is so much better than what I was trying to do. Having said that, you've got to understand what's going on. It's one thing to have a nice photograph, but then to understand what's going on. So your question around sensors and the like, you're getting red, green, and blue, the standard color cameras on that Phantom, but there are now multispectral sensors. So it depends what you're trying to target, what you're trying to do as to what you might start to get to. So, there are multispectral, it's getting near infrared, middle infrared, thermal, there are a range of sensors around. So it depends on what you're trying to do that enables you to get that. I mean, hyperspectral and even LiDAR could be useful if you're looking at, canopy structure, or, I was even quite interested in trying to put LiDAR sensors and looking at the cut wall of cane. As you're cutting the cane, you've got the next row presented to you quite nicely. Well, not some of the stuff that I've been seeing here, but I think the hurricanes probably pushed it all over. But, where you've got a nice erect stand of a cane, you know where the tops are, you know where the base cut, where the bottom of it is. Can you do some sort of sensing to adjust base cutter heights and all of those sort of things? So, there's lots of sensors. It's just the ability to find the application that's appropriate for its use and whether it's costly to do such as well. But yeah, there's plenty of sensors around. Come and have a chat later.
Yeah, and in your experience, how do you find that EC is a good indicator of soil fertility?
Depends on what's going on. EC, so things that are going to adjust the EC of the soil is, if you've got variable salinity, well, that's going to completely swamp everything else that's going on. So if your soils aren't saline, then you can start to do, we use EM or ECEM readings in Australia in clay soils, because it can start to differentiate soil types because of cation exchange and the charges of the soils, where you can start to pick up differences. You can also potentially get soil depth, long as you use it when it's appropriate. Water's a big driver in there as well. So you have to get, reasonably uniform water content. So after a very good rainfall event, or, when the soil's quite dried out after a crop's been grown and you use it, but you have to understand it. It has to essentially be, calibrated as best you can to understand what the signals are that you've got there. The beauty of it is that it's quite easy to use. It's how you layer over the top of that, the understanding, that's the $99 question to understand. Just because you've got a 3 decimal point number doesn't mean you've got that level of accuracy. You've got to understand what those numbers are, when it's appropriate to use it, but also when it's not appropriate to use it. So when, what's the best use?
Okay. Thank you.
Yeah, more than welcome, come and knock and say, Troy, what were you talking about that? Can we discuss that further? Yeah. So, yeah, can we estimate dry biomass was the question. So things like NDVI is a reasonable indicator. So what crop are you talking about? Sugarcane. The problem with, in cereal grain crops, soon as you get towards canopy closure, then stuff like NDVI start to fall over. So in cereal grain crops in Australia, where it's generally moisture limited, it's fairly useful. But as soon as you get to sugarcane, where it gets to canopy closure, then you're starting to lose that ability using something like NDVI. But there are other ways of, that people have been looking at things like LiDAR that gives you an estimate, and don't underestimate the ability of tracking things over time, like we're doing with the broccoli. If you want a one-shot, one number estimate, then that comes with its limitations. But if you track things over time, like that broccoli or the like, then the ability to monitor but also factor over the top of that, the prediction, like, as sugarcane starting to grow, the rate it's growing at, is that stable? Can you forward predict? So, NDVI through the growing season of sugarcane until it gets to canopy closure, then that ability drops off. But you might have 3 or 4 spots along that, and can you forward predict or those sort of things, or that maybe there's some other sensors out there that might be appropriate for what you're trying to do. Thanks for the ability to come and talk to you all today, and I hope my accent hasn't been too difficult to understand. Thanks, everybody.